This is Mission Control Houston. Again, we're getting ready to do an interview with Mark Weislogel of the Portland, Oregon State University. Mark is the principal investigator for the Capillary Flow Experiment. Welcome to Mission Control, Mark.
How you doing?
Doing great. Hey, we know that you're the principal investigator for Capillary Flow Experiments-2. Could you tell us a little bit about the experiment?
Yeah, these experiments are set to try to understand some complicated interaction between how liquids behave when gravity's gone in funny shaped containers. So what we're trying to do is exploit how surface tension and wetting effects combine with a strange geometry to make the liquid go where we want to in that container. So without centrifuges or without thruster firings, without any manipulation or anything, we can passively control where the liquid is in the container. And maybe you can understand how that might be important when gravity's gone, so that when you actually go to get the liquid out of a container, you can do that because you know where it is. And the same thing is when you want to get the gas out, you know where that is too. So that's our aim.
And so what kind of activities are going on with CFE this week?
Okay, we have, I believe Don Pettit is going to be doing some runs for us, looking for what we call these magic wetting conditions, where we change the geometry by rotating a vane inside a elliptical container. And at certain angles, fluid will wick up certain passageways and change its orientation. And by doing that, we can develop the math skills to predict this behavior. So we could design a tank that could actually exploit, like I said before, this shape to get the liquid all to go one direction.
And correct me if I'm wrong, but I think Don Pettit actually had some fun with this effect after we installed and activated the water recycling system on board the space station. He designed a zero-gravity cup that they could do a toast with.
Yes, in fact, we had something to do with that too. In fact, that cup exploits a similar kind of concept to what we're talking about, is where this fluid wicks up an interior corner in that container, and then you can draw from that corner just as if you were drinking on Earth, and the wetting and surface tension effects perform the same function as gravity on Earth. So it looks and feels somewhat similar to drinking on the ground. So instead of sucking from a bag, which is what I think after a while might feel a little funny.
Yeah. So what exactly in terms, how does microgravity make your experiment possible?
Okay. So when gravity's gone, what we normally see in capillary effects in small tubes and sponges, you can see in enormous systems, enormous sponges, with pore sizes on the size of a meter or something. So you see capillary phenomena like you would never see on Earth. What that does is it gives us great control over what the shape of the container is. We can build basically, complex systems that we know what the shapes are very, very well, and so our science there has much greater control compared to what we can do on the ground. It also has special application in space. We're in fluid regimes that we can't get to on Earth. So not only is it easier to study in space, but the applications are in space too. So our confidence goes way up for the things that we discover there that we want to also use there, like for spacecraft systems design.
How can we apply your research results to benefit people here on Earth?
Okay, that's happening just recently. We find that some of the rules and design tools that we are developing for the space applications are also things we can design for ground use. For instance, for what we call lab-on-chip technologies, where you have a precious small liquid sample like a blood sample, or whether it's an AIDS patient or whether it's some other test. Those reagents or those samples can go down on a chip, spread out by these capillary flow methods, and be analyzed. And so we've actually consulted on a couple of projects related to that, and they're very easy for us because of what has been developed from the space experiments.
So it's all about the math, huh?
I'm sorry to say yes, and we're delighted by that. Maybe not everybody is, but in the end, what comes out of our work is an equation. And that can be used to very efficiently and very effectively either design systems and improve processes.
And so, Mark, what's your background? Where are you from? Where'd you go to school? What's your lab like where you work now?
Okay. Well, I'm from Portland State University, and I arrived here via industry research in Colorado, and from there before actually 10 years working at NASA Glenn Research Center, and that was straight out of school and a PhD at Northwestern University. As before that, even I was moving from state to state, but I actually spent some time in Oregon too before, so I'm kind of back to a place where I went to high school. It's a great place to be. There's no NASA center in the vicinity, so folks around are interested definitely to be involved in NASA work, and some of our students have had just wonderful opportunities to be part of this research.
Well, if the recent application process is any sign, a lot of folks want to be astronauts, but there's a lot of other opportunities for people to get involved in space and space research. Do you have any advice for students or young people who might want to get into your line of work?
Okay. If they're interested, they don't know. A lot of students don't know how accessible a lot of these faculty or who are already involved are. And I think just any professor would love to meet students who are highly motivated and interested and show signs, tangible signs of that interest. And the students that we have involved, they're training astronauts. They're involved in crew procedures. They've even been enabled in space to ground to speak to the astronaut during the experiment. Don Pettit and Dan Burbank have both requested this. This is just terrific experience, very exciting. How do they tell their folks that they're doing this? It's just wonderful. And then, of course, the science that they're gathering is being published and sending those students on their ways in their career in just wonderful ways. So I would just recommend that they get pretty aggressive in identifying the work, where the work is going on that they're interested in doing, and then go for that. People love to find people who are excited about what they do.
Well, Mark, thanks for being with us. One last question for you. It's a nice day here in Houston, although it started out a little bit foggy. Are you seeing any signs of your science at work in Portland? We all hear it tends to be a little bit damp there. Are you seeing any surface tension on your windows today?
Every day. We have looked for images from space of Portland for days and days, but have never seen it because of the clouds. But that's what we deal with.
All right. Again, thank you very much, Mark Weislogel, the
Okay.
principal investigator for the Capillary Flow Experiment-2, for being with us today. And good luck on your research, Mark.
Okay. Nice talking to you.